So, hello guys, nice to see you again. The next topic we are going to talk about is the instruction set, or named instruction set architecture. An instruction is a command which tells the CPU to do some fundamental task, such as add two numbers, different arithmetical or logical operations. An instruction has an opcode which indicates the task to perform and a set of parameters which provides input to the task being performed. So each opcode represents one task that the CPU knows that is implemented by our C code. Okay, here we have the enumeration for the different opcodes, like the branch instruction, add, load, store, jump register, and so on. Okay, and they are indicated we have exactly 16 different instructions, and to indicate 16 different instructions we need exactly 4 bits. So, and it's basically like this. I think when you have watched the other videos you are familiar with this concept. So then let's go and look into some implementations of the instructions. And as you know from the videos before, each instruction is encoded by a 16-bit value that is stored at any address in the memory. So okay, first we're going to look into the add instruction. The add instruction is encoded like this. First we have our opcode, just for indicating which instruction is executed. Then we have our destination register, the first source register, the immediate flag, and then depending on the value of the immediate flag, we have two unused bit and a second source register or an immediate value. So how does this how is this add instruction implemented? So we have a destination register as mentioned here. Okay, this means we want to store the result of our operation in the destination register. So how we get this? We need the value, and we need the index of the given destination register to store some value into these register. Okay, so when we look at our instruction is encoded in exactly 16 bits in every case. Okay, so and we want the value out of exactly these 3 bits. How we are going to make this? The instruction would look like this: 0001 for the opcode. Then we have the destination register, let's say it's 110. Then we have the first source register, let's say it's 101. Then we have the immediate flag, let's say it's 1. And then we have our 5 remaining bits for the immediate value, 10110. Okay, perfect. So basically what we're going to do is shifting the instruction by 9 bits to the right. How would this look? This would look like this. So shifting 9 bits to the right. That means we are inserting 9 bits from the left side and deleting 9 bits from the right side. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And from here we have to delete 9 bits. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is our 16-bit value remaining after this operation. And we are, with this bit value, we are performing an AND operation. Why we're doing this, I come to this later. First I adding this add operator, and then we have a second value. It's 0x7. 0x7 is written in hexadecimal and basically means we have this. Okay, because the first bit at the least significant position gives us 1, the bit at the second least significant position gives us a 2, and the bit at the third least significant position gives us a 4. So 4 plus 2 plus 1 is resulting in 7. Okay, so basically 0x7 in hexadecimal gives us these 3 bits. So, and now when we're performing the AND operation with this bit value and this bit value, the AND operation, it just compares the bits at the same places. Okay, so maybe you can imagine we have 16 bits on this side too. 1 2 3 4 5 6 7 8 9 10 11 12. Okay, now we have 16 bits on both sides, and when we're performing the AND operation, the result would look like this. 1 compared with 0 results in 0. 1 compared with 1 results in 1. And 1 compared with 1 results in another one. And 0 and 1 would result in another 0. And the rest are just zeros till we have our 16-bit. And then we are going to read the value out of this bit sequence. Okay, the least significant bit would give us 0, and we just don't have to look at the zeros, only at the ones. The 1 at the second least significant position gives us a 2, and this 0 gives us a 4. 2 plus 4 is 6, and this means in this variable for R0 we just have the value 6. Okay, so this is what happens here. And here we have, now we have the value, not the value, the index for our destination register. Here we have the value 6, and this means it's just out from my example. We don't have the 6 at any time here, just in the example I created. And okay, here we have the value 6, and that would mean in this case the result is stored in register 6. The R0 does not mean we are using the R0 register. It's just a name for the variable. We are going to store in our result in the value we assigned to this variable. We are storing the value in 6, okay? And index 6 for the registers would mean 1, 0, 1, 2, 3, R7. It's our final register. No, here 6, register 6. Okay, perfect. So let's go into the next step. This was the destination register. We're doing exactly the same thing for the first source register. And then we have the immediate flag. If the immediate flag is set to 0, we are going to interpret the last 5 bits as mentioned here. These 2 bits are unused, and these 3 bits are indicating the second source register. And if the immediate flag is a 1, we are going to interpret the last 5 bits as an immediate value. So now, what is an immediate value? Immediate value is just the opposite of the register. Or no, maybe that's wrong, but a register is just indicating a storage place, and we are reading the value out of this register or writing the result in the register. And if we have an immediate value, we would read it like this. Okay, let's say it's so, and here we are interpreting these bits as just an integer. This would be 1 plus 2 plus 4, then we have a 0, this would be 8, and the last one is 16. 20, 23. So that's it. And if we have the immediate value, we're just going to add the immediate value to the value that is in the register at the place from the index from the first source register out of the instruction, and we're going to store our result at the index of the value from our destination register. It sounds very complicated, but it's very easy, yeah? Okay, and if the immediate, this would be the case if the immediate flag is set to 1. If the immediate flag is set to 0, we're just going to make the other interpretation and reading out of the index from the value given by the second source register and adding this value to the value we read out of the index given by the first source register, and then we are storing the result in our array for the registers at the place from the value out of the destination register. Okay, sounds very complicated, but I think it's very easy. When you understand it one time, it's very easy to understand. With the basic understanding of the concepts, it's very easy to understand the other instructions. I don't want to go into every other instruction by detail, because this would case a video length from 1 hour or something. Just go through the paper, and if you have some questions, reach out to me. And okay, I think there's just one remaining topic when we are talking about the instructions. As mentioned before, we have our flags and the condition register. And here we have a function update flags for the value out of the destination register. And the flags are just gives us information about the result of the last instruction, of the last operation. If the last operation has returned a positive value, the flag register is set to positive. If it was 0, it's set to 0, and if it was negative, it's set to negative. And that's it. Nothing more to talk about, nothing more to think about, just the information that is very useful sometimes. So see you in the next video.